interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond.
First, I should say that if the light that we observe from this object is a reflection of sunlight, its size needs to be bigger than Manhattan Island.
NASA's recent release on the object designated 3I/Atlas has shaken the scientific community and the wider world in a way few astronomical discoveries ever have. For years, astronomers have been tracking interstellar visitors, objects that don't belong to our solar system but pass through it, like Oumuamua in 2017 and Borisov in 2019. Yet the latest findings surrounding 3I/Atlas have forced scientists to reevaluate long-standing assumptions not only about interstellar objects but also about the very building blocks of cosmic life. The report wasn't just another routine data dump, it was filled with anomalies, revelations, and questions that cut to the heart of humanity's place in the universe. Before we start, smash the like and subscribe buttons for more updates. When NASA first detected 3I/Atlas, the excitement was already palpable. The 3I designation signaled it was the third confirmed interstellar object to be observed, a rare visitor from beyond the gravitational bonds of our Sun. Unlike asteroids and comets born in the Oort cloud or the Kuiper belt, this one originated far beyond. Its trajectory, speed, and chemical signatures bore all the hallmarks of something forged in a distant star system. But what startled researchers wasn't just its foreign origin, it was the nature of the data that didn't quite fit into any familiar pattern. Spectroscopic analysis revealed elements and compounds that hinted at processes unknown in our solar system. Certain molecular bonds appeared to form under extreme conditions that current astrophysical models cannot replicate in theory. Some of these compounds carried striking similarities to amino acids and carbon-rich molecules, suggesting that 3I/Atlas might have transported prebiotic ingredients across interstellar space. The implications were staggering. For decades, the panspermia hypothesis, the idea that life seeds may travel between worlds on comets or meteors, was largely relegated to speculative corners of science. Yet here, in NASA's official findings, was evidence that could place panspermia on much firmer ground. What startled the public most, however, wasn't the whisper of life's chemical precursors, but the object's structural features. High-resolution imaging showed geometric formations across its surface, ridges, grooves, and lattice-like layers that looked eerily intentional. While natural processes can create surprising shapes, some of these patterns resisted easy explanation. NASA's language in the report was careful, never declaring them artificial, but the wording suggested the agency's own experts were at a loss. To find such features on a body hurtling from another star system set imaginations ablaze. Was this merely a quirk of physics, or had humanity stumbled upon something more? The report further detailed unusual energy emissions recorded from the object. While many comets outgas when heated by the sun, releasing jets of gas and dust, 3I/Atlas produced rhythmic pulses of energy that did not match simple sublimation. These emissions appeared modulated, almost timed, with a regularity that drew comparisons to signals rather than natural outbursts. The data compelled NASA to double-check every calibration, ruling out instrument error. What remained was a dataset that suggested patterns beyond randomness, an unsettling possibility that forced both caution and wonder. Scientists from multiple disciplines immediately converged on the object's mystery. Astrobiologists focused on the organic molecules, seeing in them the blueprint of what could evolve into life. Planetary geologists puzzled over the structural ridges, attempting to model how impacts, heat stress, or cryovolcanic activity could produce such formations. Physicists examined the energy pulses, running simulations of exotic chemical reactions or magnetic phenomena. Yet, despite these efforts, the report left more questions than answers. It wasn't just the strangeness of one anomaly, but the convergence of several that made 3I/Atlas unlike anything ever recorded. The implications extended beyond science. Philosophers, theologians, and futurists latched onto the findings with fervor. If interstellar objects carried complex organic material, then the universe might be a vast network of life's building blocks, scattered like seeds across the stars. Humanity's existence could be less a fluke and more an inevitability, one expression among countless others. The possibility of intentional design hinted at by the geometric surface formations and rhythmic emissions touched on questions that blurred the line between science and metaphysics. Were these the scars of natural processes, or signs of something made? Within the astronomical community, excitement was tempered by the recognition of just how fragile our understanding remains. Each interstellar object is fleeting, passing through the solar system in a matter of months or years before disappearing into the void forever. Opportunities to gather data are rare, and 3I/Atlas presented a chance that could not be squandered. The NASA report emphasized the urgency of coordinating telescopes worldwide, pooling every available resource to track the object, map its path, and extract every possible observation before it was gone. The sense of racing against cosmic time added to the weight of the findings. One particularly shocking detail buried in the report involved isotopic ratios found in the object's outgassing materials. These ratios did not align with any known stellar formation models. That meant 3I/Atlas may have originated from a star system profoundly different from anything yet cataloged, perhaps orbiting a type of star not considered capable of supporting complex chemistry. The notion that life's building blocks, or something resembling life, could emerge from such alien conditions shattered long-standing assumptions about where habitability could exist. Suddenly, the universe seemed less restrictive and far more fertile. The political world, though not explicitly mentioned in NASA's technical documentation, could not ignore the implications. If interstellar travelers carried ingredients of life or signs of artificiality, then questions of ownership, stewardship, and contact were no longer theoretical. Governments and agencies around the globe began quietly reassessing their priorities. Investment in deep space detection systems and advanced propulsion suddenly seemed less like science fiction and more like strategic necessity. The possibility that objects like 3I/Atlas might one day deliver more than just mystery, whether danger or opportunity, loomed large in the minds of policymakers. The psychological impact on the general public cannot be understated. For centuries, humanity has stared into the night sky with a sense of awe and isolation. The data on 3I/Atlas chipped away at that isolation. Even without definitive proof of life or technology, the convergence of strange chemistry, inexplicable patterns, and rhythmic emissions was enough to fuel imagination across the world. Conversations about extraterrestrial intelligence shifted subtly. No longer confined to speculative fiction, they began to seep into mainstream discourse, emboldened by the credibility of NASA's findings. People began to ask not whether we are alone, but how we might recognize the signs of others if they crossed our path. The report also sparked renewed interest in space exploration. If interstellar objects can deliver unprecedented insight into other star systems, then capturing or visiting them could become one of humanity's most important scientific endeavors. Engineers began discussing theoretical missions that could rendezvous with future interstellar objects, attaching probes or deploying sample return mechanisms. These ideas, once considered far-fetched, now carried the urgency of real possibility. 3I/Atlas was not just a curiosity. It was a herald of discoveries to come, if humanity dared to follow. The timing of the discovery added yet another layer of intrigue. As technology on Earth advances rapidly in artificial intelligence, quantum computing, and deep space observation, the sudden appearance of a mysterious object with unexplained features felt almost symbolic, as though the universe were presenting humanity with a challenge. Were we ready to confront mysteries that stretch beyond our current paradigms? Could our collective imagination expand quickly enough to grasp the implications without collapsing into fear or denial? The NASA report, dense with data but tinged with wonder, left the impression of a species standing at the threshold of something vast. Amid all the excitement, one detail resonated deeply with those who studied the report carefully. The object's trajectory suggested it had not wandered aimlessly into the solar system, but had passed within striking distance of several planetary systems before arriving here. Whether this was mere coincidence or part of a grander pattern remained unknown, but the precision of its path invited speculation. Could interstellar objects follow invisible highways shaped by gravitational currents? If so, then perhaps 3I/Atlas was not the first of its kind to pass through unnoticed, and it certainly would not be the last. The cosmos may be alive with travelers, carrying secrets between stars. For scientists, the immediate task remains data collection and analysis. Every photon captured, every spectrographic reading, every trajectory calculation could unlock new chapters of cosmic history. Yet beyond the technical rigor lies something more profound. 3I/Atlas has reignited a sense of wonder that transcends disciplines. It has shown that even in an age of satellites, supercomputers, and precision science, the universe can still surprise us with something so unexpected that it forces a reevaluation of our place in the grand scheme. The shock of NASA's report wasn't in claiming answers, but in unveiling mysteries deeper than anyone anticipated. As the object continues its journey out of the solar system, humanity is left with the indelible memory of its passing and the seismic impact of what was learned. The chemical hints of life, the geometric structures, the rhythmic emissions, the alien isotopic ratios, all converge into a picture of a cosmos more dynamic, more interconnected, and perhaps more inhabited than previously dared. The shockwaves of NASA's report will echo for years, inspiring exploration, debate, and reflection. 3I/Atlas, though transient in the sky, has etched itself permanently into human history, not as an answer, but as a question so profound that it may define an era. The revelations about 3I/Atlas did not just end with NASA's initial findings. They opened an entirely new realm of inquiry that spread across countless branches of human thought. Once the immediate shock of the report began to settle, experts in multiple fields pressed further into questions that had never before seemed practical to address. The data was not merely anomalous, it was disruptive. It forced scientists, scholars, and even strategists to begin thinking about interstellar phenomena not as distant curiosities, but as direct elements of human reality. To extend the significance of what has been uncovered, it is worth delving deeper into the many dimensions this discovery touches, dimensions that stretch far beyond astronomy alone. Another arena opened by the discovery involves the dynamics of interstellar travel itself. The trajectory of 3I/Atlas was so precise, so elegantly arched through the solar system, that gravitational analysts began to suspect it was not simply wandering. Natural or not, its course demonstrated how interstellar objects could exploit cosmic mechanics to travel across unimaginable distances. This prompted renewed interest in the study of gravitational slingshots and interstellar highways, currents of space shaped by the pulls of stars and black holes. If nature crafts such corridors, humanity might one day navigate them, turning chance discoveries into deliberate journeys. 3I/Atlas became a proof of concept for interstellar navigation, not in theory but in practice. Moving beyond physics, the chemical complexity of the object demanded new frameworks of thought. Laboratory replications of its molecular data showed interactions that did not fit neatly within the known periodic table's limitations. Some of the compounds hinted at high-energy bonding states possible only under pressures or temperatures outside Earth's environment. The implications here are vast. Such compounds could reveal new pathways of chemistry, perhaps forming a bridge between inert matter and the precursors of biology. For astrobiologists, this raised the possibility that life might emerge under conditions previously dismissed as too harsh or too alien. The comfort zones of the habitable zone around stars suddenly seemed too narrow. Life's building blocks might not require Earth-like conditions at all. They could form, thrive, and evolve under the icy, the fiery, and the exotic. The data from 3I/Atlas became a cornerstone in reframing the very definition of habitability. Equally transformative was the cultural dimension. For centuries, the idea of life beyond Earth has oscillated between myth, speculation, and scientific pursuit, yet rarely has evidence emerged that forced humanity to confront the possibility so directly. The shock of NASA's report rippled through art, literature, and philosophy. Creators began producing works not about whether extraterrestrial life exists, but about how its existence reshapes human identity. Are we still singular in our narrative, or just one story among many in a galactic anthology? This shift was subtle but powerful, changing the tone of cultural production from searching to responding, from asking to imagining answers. The very symbols humans attach to the cosmos, from the ancient zodiac to modern science fiction, gained new resonance under the weight of real, unexplained evidence. The field of communication science also found itself unexpectedly relevant. The rhythmic emissions documented by NASA, while not conclusively artificial, bore a resemblance to patterned signals. This opened the door to a wave of analysis rooted in information theory. Mathematicians and codebreakers began applying statistical methods to determine whether the pulses contained structure akin to language or data. Even if ultimately natural, the process revealed how humanity might one day recognize non-human communication. Patterns of rhythm, repetition, and variation are the hallmarks of information transfer. The emissions of 3I/Atlas, in provoking such inquiry, provided a training ground for developing protocols that might be crucial should contact ever be made with genuine extraterrestrial intelligence. Beyond science and culture, the discovery also thrust itself into the realm of geopolitics. Nations, already competing in the arenas of space mining, defense, and exploration, now had to consider the significance of interstellar arrivals. What if 3I/Atlas had contained not just data, but material resources unlike any on Earth? What if such objects were more common than expected, drifting through space as potential treasure troves? The report spurred conversations about who, if anyone, has the right to claim or study interstellar objects. International law, still struggling to keep pace with Earth-orbiting satellites and lunar missions, suddenly seemed woefully inadequate to deal with bodies from beyond the solar system. The debate touched on sovereignty, ethics, and responsibility on a scale far larger than any prior discussion of outer space. From a technological perspective, the report sparked visions of new missions. Space agencies began drafting theoretical proposals for rapid response spacecraft, machines that could launch within weeks to intercept the next interstellar visitor. The technology required for such missions is immense, involving propulsion systems that far exceed current rockets and detection systems sensitive enough to catch faint signals years in advance. Yet the incentive has never been clearer. To observe from afar, as with 3I/Atlas, offers only fragments of the truth. To touch, sample, and return would unlock answers hidden in the heart of such travelers. NASA's shocking findings did not just illuminate mysteries. They lit the fire of ambition, daring humanity to build what it has never built before. The academic implications ripple endlessly. Universities began reshaping research agendas, emphasizing interdisciplinary collaboration. Physicists, chemists, biologists, philosophers, and linguists now shared common ground in the mystery of 3I/Atlas. Graduate students drafted theses not just on astrophysics, but on the ethical and existential dimensions of contact. Conferences became stages not only for data presentation, but for debates about meaning. Education itself shifted slightly, preparing the next generation not just for scientific precision, but for cosmic humility. To study 3I/Atlas was to acknowledge the limits of human understanding and the vastness that lies beyond. Perhaps one of the most fascinating consequences of the NASA report lies in the field of time. By analyzing isotopic ratios and decay rates, scientists attempted to estimate the object's age. The numbers suggested origins billions of years older than our solar system, perhaps tied to stars that no longer even exist. This temporal depth challenges human perception. To examine 3I/Atlas is to look into a past so distant it defies imagination. It is to hold, however briefly, a fragment of history older than the Earth itself. Such temporal immensity shifts perspective. Humanity is not only small in space, but fleeting in time. The object reminded the world that the cosmos is a continuum of stories written across billions of years, and humanity is but a recent addition to its pages. Ethics, too, found fertile ground in the wake of the report. If 3I/Atlas carried prebiotic material, should humanity treat it as sacred, a vessel of potential life? If its structures hinted at artificial design, should it be preserved as a relic rather than mined or exploited? Philosophers debated whether the cosmos itself demands a form of stewardship, not just of planets, but of the travelers that pass between them. The discovery made clear that exploration is not only a technical act, but also a moral one. The choices humanity makes in responding to such mysteries may shape its legacy far more than the discoveries themselves. In medicine, oddly enough, implications emerged as well. The exotic compounds found on 3I/Atlas suggested possibilities for chemistry unimagined on Earth. If synthesized or studied further, such compounds might reveal new pathways for pharmaceuticals, materials resistant to radiation, or catalysts for biochemical processes. Though speculative, the medical world paid attention. recognizing that life's mysteries might be unlocked, not only on Earth, but in the wandering debris of the galaxy. The potential for interstellar chemistry to one day save lives added yet another layer of urgency to study these fleeting visitors. For ordinary people, the discovery did more than inspire awe. It reshaped daily imagination. The night sky no longer seemed a distant, decorative canopy, but a highway of travelers, each carrying secrets. Amateur astronomers turned their telescopes upward with renewed vigor. Schools reported surges of interest in science clubs. Social groups gathered to debate the meaning of NASA's findings, blending science with spirituality, wonder with fear. The impact of 3I/Atlas was not limited to laboratories or boardrooms. It became a part of conversation at dinner tables, a spark in classrooms, a whisper in the minds of children staring upward with dreams far beyond Earth. Perhaps the most profound implication lies in the existential. The discovery forced humanity to reconsider its isolation. If objects like 3I/Atlas carry the building blocks of life, then the universe itself may be alive with potential. If its structures or emissions carry hints of intelligence, then humanity is not alone in thought. Either possibility redefines what it means to exist as a species. No longer the sole authors of meaning, humans might be participants in a grander dialogue written across the stars. The shock of NASA's report was not only in its data, but in its demand that humanity confront itself, not as the center of the universe, but as a part of it. 3I/Atlas will eventually slip away, its mysteries carried back into the infinite dark, yet its impact will remain. The knowledge gained, the questions provoked, and the imagination ignited will not vanish with it. Instead, they will shape the course of science, culture, and philosophy for generations. The report stands as a marker, a moment when the universe revealed a glimpse of its deeper truths and left humanity forever altered. To encounter such a traveler is to be reminded that the cosmos is not silent, not still, and not empty. It is alive with stories, waiting to be read, and 3I/Atlas is one of its most startling chapters. The fascination surrounding 3I/Atlas continues to deepen as researchers extend their thinking beyond the immediate scientific results. The shock of NASA's findings has proven to be more than a temporary sensation. It has become a springboard for speculations, theories, and practical pathways that stretch across nearly every human discipline. While the first waves of analysis focused on chemistry, structure, and trajectory, the object also carries implications in less obvious domains that have only begun to unfold. By considering these additional perspectives, one sees that the significance of 3I/Atlas extends well beyond the boundaries of astronomy. This leads naturally into the philosophy of science. The revelations of 3I/Atlas have compelled scholars to revisit the boundaries of falsifiability and the role of anomaly in discovery. For decades, anomalies have been brushed aside as noise until they accumulate into undeniable patterns. The sudden convergence of anomalies in 3I/Atlas, the chemistry, the emissions, the structures, created a situation in which the anomaly became the central focus. Philosophers of science note that this represents a shift in epistemology. Rather than assuming that strangeness must eventually yield to normal explanations, it suggests that strangeness itself may be a fundamental feature of reality. In this sense, 3I/Atlas acts not only as an astronomical object, but also as a philosophical fulcrum, demonstrating the limits of human frameworks when confronted with the truly alien. Theological circles, too, have found themselves grappling with the discovery. While some religious traditions have long anticipated the possibility of life beyond Earth, others are wrestling with the implications of cosmic diversity. If the building blocks of life are scattered through the stars, then creation itself may be far more expansive than once believed. The theological question shifts from whether humanity is alone to how human spirituality integrates into a broader tapestry of existence. Some traditions view 3I/Atlas as a divine sign of universality, while others interpret it as a test of humility. Regardless of interpretation, the fact remains that a single interstellar visitor has sparked discussions that ripple into the deepest questions of purpose and meaning. Art and creativity have also flourished in the wake of the discovery. Artists see in 3I/Atlas not just a scientific puzzle, but a muse. Painters render its ridged surface as surreal landscapes. Writers imagine civilizations that might have encountered similar objects in other corners of the galaxy, and musicians translate its rhythmic emissions into compositions. The arts become a mirror of collective wonder, giving form to ideas that science alone cannot capture. Just as the Apollo missions once inspired a wave of cultural expression, so too does 3I/Atlas ignite imaginations, blending fact and interpretation into works that resonate across societies. In this sense, its legacy will not be confined to labs and telescopes, but will echo in galleries, libraries, and concert halls. Another dimension lies in the study of risk. Interstellar objects are not simply neutral, their unpredictable paths pose potential hazards. While 3I/Atlas itself did not threaten Earth, its unexpected trajectory reminded scientists of how vulnerable the planet remains to cosmic encounters. Risk analysts have begun integrating interstellar dynamics into their models, considering what might happen if a similar object crossed paths with Earth. Unlike near-Earth asteroids, which can be tracked within the solar system, interstellar visitors appear with little warning, traveling at immense speeds. This realization has driven discussions about planetary defense strategies that extend beyond known asteroid belts. Protecting Earth now demands a vigilance not only against local threats, but also against those arriving from the far reaches of space. Economics, too, finds itself entangled in the implications of the discovery. If 3I/Atlas carried materials unknown to Earth, then future interstellar objects might contain resources of immense value. Even the hint of exotic compounds creates speculation about markets, investments, and technological revolutions. Companies in aerospace and mining industries are already considering the potential of rapid response missions not only for science, but for resource acquisition. The economics of space, once a long-term prospect tied to lunar or Martian projects, now finds itself reoriented toward fleeting opportunities from interstellar wanderers. The prospect of scarcity shifting to abundance, through access to materials forged in alien star systems, has begun to reframe how economists think about global futures. Education systems are also undergoing subtle shifts. Teachers, eager to harness the excitement sparked by NASA's findings, incorporate 3I/Atlas into curricula to inspire students. The object becomes a teaching tool not just for science, but for cross-disciplinary thinking. It allows lessons in chemistry, physics, philosophy, art, and even civics to converge around a single real-world event. The effect is transformative. Instead of compartmentalized learning, students see knowledge as an interconnected web, mirroring the way the discovery itself bridges disciplines. The educational impact may prove one of the longest-lasting consequences, cultivating generations inspired not by distant hypotheticals, but by a real moment when the universe revealed its strangeness. One cannot overlook the psychological dimensions. Humanity has always carried an undercurrent of cosmic anxiety, the fear of insignificance in an immense universe. For some, 3I/Atlas deepens this anxiety, underscoring how small and fleeting human civilization appears next to billion-year-old travelers. For others, it offers relief, a reminder that humanity is part of something vast and interconnected. Psychologists note that such events often serve as catalysts for what is known as the overview effect, a shift in consciousness similar to what astronauts experience when viewing Earth from space. This collective overview effect could reshape cultural values, moving societies toward greater emphasis on cooperation, stewardship, and humility. In technology, the discovery has stimulated renewed urgency in propulsion research. If interstellar visitors can travel immense distances across space, then humanity faces the challenge of following them. Concepts like light sails, nuclear fusion drives, and even antimatter propulsion are no longer speculative dreams, but necessary pursuits if scientists hope to study such objects directly. The fleeting presence of 3I/Atlas highlighted how inadequate current technology is for seizing opportunities of this scale. The drive to innovate is no longer just about reaching planets within our solar system, but about preparing for encounters that originate from beyond it. In this way, the shock of the discovery has accelerated technological ambition. Sociology also finds relevance in the event. The collective reaction to NASA's report provides a unique case study in how societies handle paradigm-shifting knowledge. Unlike purely scientific news, which often circulates quietly, the revelations about 3I/Atlas captured public imagination immediately. Sociologists observe how media, cultural narratives, and social networks amplified the sense of wonder and fear. They note how belief systems, scientific, spiritual, and conspiratorial, intersected to form diverse interpretations of the same data. Studying these reactions offers insight into how humanity might one day respond to more direct evidence of extraterrestrial life or intelligence. In this sense, 3i/Atlas served as a rehearsal for larger revelations yet to come. Law and governance find themselves equally challenged. Current space treaties were written with satellites and planetary exploration in mind, not interstellar visitors. The question arises, who owns the right to analyze, mine, or preserve such objects? Should they be considered global heritage accessible to all humanity, or are they open to claims by those with the technology to reach them? The absence of clear frameworks creates a legal gray zone, one that could easily become contentious as more interstellar objects are discovered. Policymakers are beginning to recognize that governance of space must expand to include not just human creations, but also natural arrivals from other star systems. Another profound angle is the role of language. In describing 3i/Atlas, scientists struggled to find words that captured its uniqueness without overstating claims. The balance between caution and imagination proved delicate. Terms like geometric and rhythmic carried implications that hinted at artificiality, even if not intended. This revealed how language itself shapes public perception of discovery. Linguists note that as humanity encounters more interstellar phenomena, new vocabularies may be required. Words that capture forms, behaviors, and concepts outside terrestrial experience. In this sense, 3i/Atlas not only expanded science, but also stretched the boundaries of human expression. The ecological metaphor offers yet another frame. Some biologists suggest that interstellar objects could be understood as seeds or spores within a cosmic ecosystem. Just as pollen drifts across continents to fertilize distant plants, so too might objects like 3i/Atlas drift across galaxies to spread materials, energy, and possibility. If this metaphor holds, then the universe is not a cold void, but a living field of exchange, where even seemingly inert rocks contribute to a larger cycle of cosmic ecology. This perspective transforms the discovery into a story of connectivity, where life is not isolated but interwoven through the movement of matter across the stars. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA's shocking report about 3i/Atlas new data? We want to hear from you. Thank you for watching, and see you next time.